Okay, our next review topic for algebra now goes into evaluating and simplifying an algebraic expression. Evaluating and simplifying an algebraic expression. First thing we need to look at is what an algebraic expression is. Simply a combination of numbers, operations, and variables. So there are four main parts to an algebraic expression. Terms are parts of an algebraic expression separated by a plus or minus sign. So those you have 5x and you have the minus 3, that's two terms. So it's two terms. Variable represents an unknown quantity, so that's x. Constant is the number term that is not attached to a variable. So this 3 is the constant. Since there's a minus sign in front of it, it would be considered a negative 3. Coefficient is a number that is in front of a variable. This number is multiplied to that variable. So 5x, the coefficient is 5. So that's 5 times whatever x is equal to. So brief overview of the individual parts of an algebraic expression. Now let's look at evaluating it. To evaluate an algebraic expression, first you substitute the values of the variables into the expression. So that's when you're just plugging in. And then you solve out using the order of operations. So we're going to quickly look at what the order of operations is and dispel one particular hiccup that a lot of students run into. First step, work out anything that's inside or underneath parentheses, square roots, absolute values. So if it's inside of a parentheses, underneath a square root, or inside of an absolute value, it must be worked out first. You have to get it down to a single number. Second, work out the exponent, the square root, or the absolute value. So once you have a single number raised to an exponent, or a single number that you're taking the square root of, or a single number that you're taking the absolute value of, then we can go ahead and work it out. That would be your second step. Third step is to work out multiplication or division going from left to right. The key thing here is left to right. So these two can be out of, multiplying and dividing can be out of order because you have to work from left to right. For example, if you have 36 divided by 4 times 3, you must do 36 divided by 4 first because that comes first going from left to right. If you do 4 times 3 first, you're going to get the wrong answer. You're going to get the wrong answer inadvertently. So just be careful. Last step is to add or subtract from left to right. Again, the key thing there is from left to right. Always work from left to right. So if you have 17 minus 9 plus 4, you have to do 17 minus 9 first because it came first going from left to right. If you don't, you're going to end up with the wrong answer inadvertently. So just make sure you pay attention to what's going on. So now we're going to go through evaluating expressions. We're going to start with a simple one-step computation and then work our way along. Example 1, evaluate g minus 14 when g is equal to 33. So the first step is to take 33 and plug it in for g. Take 33 and plug it in for g. Then you just do the computation. In this case, 33 minus 14 is 19, and that's that. Example 2, 14 plus 5h when h is equal to 2.6. Remember, when a number is next to a variable, that's multiplication. So this is really 14 plus 5 times h. You don't have to write it out the way that I did. I'm just illustrating for you that that means multiplication. But take the number, plug it in, and then we follow the order of operations. So first is parentheses. There's nothing for us to work out inside the parentheses. It's just one number. Exponents, there aren't any. Now we multiply or divide going from left to right. So if I go from left to right, that's adding, but this is multiplying. So we need to take 5 times 2.6, which is 13. And 14 plus 13 is 27. 14 plus 13 is 27. Example 3. Evaluate n squared plus 7 when n is equal to negative 3. So now we're going to be plugging in a negative number. When you plug in negative numbers, it is strongly advised, i.e. I'm telling you to do it, put the negative number in parentheses. Take that negative number, and when you plug it in, put it in parentheses. The reason why I ask you to do that is when you use your calculator, if you do use your calculator, that's going to give you that clue of put it in parentheses in the calculator as well, because it's very easy to mess that up if you don't. Now we solve it out. Parentheses, we don't have any parentheses. So we have negative 3 in parentheses, but that's just a single number, so we're good. Exponents. Negative 3 squared, so remember that's negative 3 times negative 3. That's positive 9. We don't have any multiplying or dividing to take care of, so we just need to do 9 plus 7, which is 16. That takes care of example 3. Example 4. You got 2x squared plus 3y when x is equal to negative 4 and y is equal to 5. So again, a number next to a variable means multiplication. So this means 2 times x squared plus 3 times y. Again, you don't have to write it out like that. It just tells you what it means. So, first step, take your numbers and plug them in. Take your numbers and plug them in first. Then we follow PEMDAS. P is parentheses. We have 2 parentheses, but there's only one number in them, so there's nothing we need to do. Second step is exponents. I have an exponent in negative 4 to the second power. So negative 4 to the second power is positive 16. So now this is what I have. 2 times 16 is 32. Remember, multiplication comes next. Multiplying or dividing. 2 times 16 is 32. 3 times 5 is 15. Now you can go ahead and add 32 plus 15 is 47. 32 plus 15 is 47. Excellent. We're going to do 2 more concept-related problems, and then we'll try a couple word problems too. Example 5. Find the value of the square root of AB minus 13. A is 24 and B is 6. First thing I want you to keep in mind, this minus sign and that 13 are not underneath the square root. That's important. Because if you put them under the square root, you're going to end up with a much different answer. So just be careful. First thing you need to do is plug in the numbers that you have. So that's 24 times 6, and then a minus 13 is on the outside. Then we follow PEMDAS. So we start with parentheses. Remember, parentheses also includes anything under the square root. So you have two numbers under the square root. We multiply them together. That gives you 144. But we still have the square root. So now we take the square root. The square root of 144 is 12. That gives you 12 minus 13. And from there, there's nothing else that you really need to solve except for 12 minus 13, which is negative 1. Lastly, example 6. Find the value of the absolute value of 1/2 x squared plus 5x minus 7 when x is equal to negative 6. So this one has a lot in it, so let's work it out. Take negative 6, plug it in for x. Notice that you see x twice. Since x is there twice, you plug it in twice. X was there twice, so you plug it in twice. So that's the first step. Next step is actually to solve it out. First step with PEMDAS, start in parentheses. Parentheses also includes anything inside of an absolute value. So we work inside the absolute value. We've got an exponent, so we need to take care of that. Negative 6 to the second power is positive 36. We have no other exponents, so now we multiply or divide from left to right. 1/2 times 36 is 18. Plus 5 times negative 6 is negative 30. Minus 7. We keep bringing down the absolute values because we haven't taken it yet. We stay inside the absolute value. 18 plus negative 30 is negative 12. And then negative 12 minus 7 is negative 19. So we have the absolute value of negative 19. Now we just have a single number inside of the absolute value. So now we can actually do it. The absolute value of negative 19 is positive 19. And that's your final answer for that problem. So this one was a little bit more involved, but if you follow the steps carefully, everything works out. So, as I mentioned, we're going to try a couple more problems together as well. Both of them involve evaluating an expression. Example 7, the formula A equals P, parentheses, 1 plus R to the T power, represents the ending value A of a bank account with a beginning deposit P and an interest rate R after T years. Find the ending value A of an account that started with $4,000 after 6 years at an interest rate of 3%. Convert the percent to a decimal before starting the problem. So there's a lot in that problem, but it's nothing that we can't handle. So here's the formula that we're working with. Let's search our problem and get the information. So it told us to find the ending value, so we don't know what A is equal to. They told you that you started with $4,000. So that's your beginning deposit. So P is equal to 4,000. After 6 years, so they're telling you that T is equal to 6, at an interest rate of 3%. But 99% of the time, when you plug into a formula with a percent, that percent has to be changed to a decimal. So to change a percent to a decimal, you divide by 100. You divide by 100. So you take 3 divided by 100, which is 0.03. So that number is what would go into the formula. That's the number that would go in the formula. So now we plug in what we have. That's 4,000 times 1 plus 0.03 raised to the 6th power. So now we're ready to do some work. Follow the order of operations. So we start inside the parentheses. 1 plus 0.03 gives you 1.03. After parentheses is exponents. So exponents, you have 1.03 raised to the 6th power. So you have 4,000 times 1.194052297. Now, your teacher would probably have you stop after a few numbers after the decimal place. I'm just putting everything for the purposes of this video. So the last thing you need to do is multiply them together. So take 4,000 and multiply times that number. You get 4,776.21. So that would be your ending balance. And the reason why I only went to 2 decimal places is because this is money. Money always rounds to 2 decimal places. Always remember that. Money always rounds to 2 decimal places. So any problem dealing with money, round to 2 decimal places, which is the nearest 100. And our last question for this concept. 1 tablet of Tylenol extra strength medicine contains 650 milligrams. Once entering your body, it dissolves, decreases at a rate of 18 milligrams per minute. So part A is asking us to write an expression that represents the amount of medicine left in your body after M minutes. So think about what it asked you, what it told you. 1 tablet contains 650 milligrams, and it's dissolving at a rate of 18 milligrams per minute. That means each minute, 18 milligrams is leaving your body. It's dissolving into your bloodstream. So to write the expression, you started with 650 milligrams. So dissolving means it's decreasing, and decreasing means subtraction. 18 milligrams per, we don't know how many minutes it's in our system. So that would be your expression that you would solve, for example. Part B is simply asking how many milligrams of the medicine is still in your body after 30 minutes. So that means M is equal to 30 minutes. We take 30, plug it in. Then we solve out using order of operations. Parentheses is only a single number. We're good. There's no exponents. We have multiplication. That's 18 times 30, which is 540. 650 minus 540, if you do the computation, gives you 110. So there's 110 milligrams still in your body. So it's definitely a lot to digest. For some of you, this is review. For some of you, this is a good chance to go over those key concepts again so that you're better prepared for the algebra that you will work with.